Hello there, it's Jay here from Jay's Vintage Junk, and today we're going to be testing some RAM basically. If you're watching my videos on the Amstrad PC1512 refurbishment, you'll know I've got that second board that I want to get working, and there's some DRAM missing from it. Now I've got plenty of DRAM to actually try and repopulate that board with, but I've got basically one problem. A few weeks ago I was actually bringing a lot of my components from where I used to store them down into the new workshop I have here. In fact, I've got some really nice, I'll spin the camera around, you can see what I've basically been doing. So if we go up and round here, we can see basically we've got most of my components now in these nice drawers. Now these were all stored up at one of my storage areas, and I decided I would actually get round to bringing them all down. And most of it was quite successful. You know, I brought them all down. They weren't quite looking like that. I've done new labels on a lot of the drawers, and I've sorted a lot of the drawers out. But those drawers, when I got them quite a few years ago, weren't exactly in the best of conditions. And the cabinets have deteriorated somewhat. They're old metal cabinets. Like I say, I've done quite a bit of work to get them so I can use them again. And unfortunately, when I was carrying one of the cabinets down from my workshop to get it in my truck, the cabinet basically just fell apart in my hands. And I think you can guess what happened. Essentially, this is currently all my sorted DRAM. It went everywhere. It must have took me the best part of an hour to pick it all up. So I had it all in drawers basically by what the RAM was, by its speed, by its manufacturer. So you know, if I needed a bit of DRAM for something, I could go to a drawer, open it, and I knew I had some working DRAM there, and it's all ended up like that. So I've got a lot of work ahead basically to resort all this, get it back in. I've got some new drawers for it to go into, but I need to basically sort all this back out again and, you know, re-go through it all. What it does mean though is I can go through and test it all while I'm doing it as well. And I'll basically, what I'm going to do in this video is just show you the setup I've got for doing that. So we know we need some Texas Instruments. I think the 4256s or something like that at 150 nanosecond. So what I'll do, first of all, I'll do it off camera so it doesn't make this video too long, but I'll go through this box, I'll fish out a couple of them TI chips, and then we'll have a quick look at what I've got of my setup here, how we're actually going to test them, and we'll run through and we'll test a few of those Texas Instruments DRAM chips, so we know we've got them ready, good and tested for going in the Amstrad board. I might throw a few other a few of the other DRAMs I've got here through the tester and just show you. It's very, very good actually. It can test a lot of the old DRAMs. I'll show you the software and what have you, because it's basic, it's old. It even runs on I've got my Toshiba T1000 here, and this is what we're actually going to use to run the software for the tester. Anyway, I'll get you set back up so you can actually see more of what's going on, and we'll have a go at testing some of this DRAM. So back in a sec. Right, we've got this. Basically, here's the setup. So we've got the Speedmaster 1000 here. This is an nice Speedmaster 1000. It's basically, it's an EEPROM programmer that can do a lot of other things. It can program PALs and GALs, it can test 74 series logic ICs, it can test DRAM. So it's a very, very, very useful piece of equipment. There are some of the more modern, cheap Chinese EEPROM programmers that can actually do a lot of the things that this can do. Although this can program far more larger EEPROMs than some of those cheap Chinese EEPROM programmers can. It's something that I'm absolutely delighted to own. This I got it at a very, very good price, put it that way. It came in a big job lot of computer parts that I bought a few years ago. And it is an incredibly useful piece of equipment. Anyway, I've had a fish and a fertile through that box, and I've managed to dig out. I know I've got more of these, but I weren't hunting all the way into the bottom of the box. I've got 3 of the these are Texas Instruments TMS 4256-15, so they're 150 nanosecond. These are exactly what we need for the Amstrad PC. And we've got 3 of them, and we need 3 of them. So hopefully, all 3 of these will actually work. If not, like I said, I'm sure there are more of them in that box. If not, I have got plenty of other DRAM which will be compatible. It's just not going to be the same make. And it would be nice to have the board with all the same brand of DRAM on there. Anyway, this is really very, very simple to do. The only thing you have to make sure is you actually put the IC in the socket in the correct place, because depending on what you're doing with it, actually is dependent on how you actually place the IC in the socket. For the DRAM, it essentially goes in exactly the same as if you was to be burning an EEPROM or reading an EEPROM in this, as in pin 1 goes to pin 1 at the top of the ZIF socket. So we drop it into the programmer like that. We pull the lever down to lock it in place. I'll get you over onto the screen so you can actually see what the software is doing, rather than look at that. Let me zoom you in a little bit. There we go. Hopefully you can see that. Now, obviously we're running this on the Toshiba T1000, so you're looking at the composite output of a CGA display basically on there. But to be honest, it's quite displayable. For some bizarre reason, though, I can only get the T1000 to display on that one monitor on the set of monitors I have on the desk here. My T1200 will work on all, well, I'm not trying it on the end one, but it'll certainly work on the green screen, because I was playing about with that the other day. But I cannot get this T1000 to work on the green screen monitor, but it works absolutely perfectly on the LCD at the end there. Anyway, I'm rambling now, so let's see. If you look here, we've got all the options. So we've got the 7400 series test, 4000 series test, a user library where you can basically set for your own ICs, an SRAM library for testing SRAM ICs, and then the DRAM library, which is what we're interested in at the moment. So we'll go down to the DRAM library there, select on that, and it's actually reminding us now that the DRAMs are positioned with pin 1 in the pin 1 position of the ZIF socket. Like I said, if you was testing, say, the 7400 series, they actually go in the ZIF socket in a slightly different way. So we can press a key, and then we want to select the device. So basically we click select device, and it gives us the options here. So we've got 64 by 1 bit, that's 64K by 1 bit, which is a 16 pin IC. Or we've got 256K by 1 bit, which is basically what we want to test here now. We can also test, this is what's really nice about this this piece of software, or this tester. We can also test 64K by 4 bits, so that's the larger, that is, let me see if I've got one I can show you. Yes, I have actually. That is basically those there. Those are like the 4-bit chips. So we can test those. We can test 1 megabyte by 1. I believe they're used in things like Amigas and stuff like that. We can test the 256K by 4. Again, that's what was used on the PC1512, the later version, the second revision of them for the upgrade RAM. And we can also test the 1 megabyte by 4-bit ICs. I don't actually think I've got any of them, to be honest. But the one that we are interested in is the 256K by 1 bit 16-pin IC. So we'll select that, and we can then go down to test device. We'll hit test device, and if you look here, it's marching ones through 256k, and then it's marching zeros through, and there it's telling us the RAM is okay. So that's one of the RAM checks tested good. We'll take that out, or put another one in. We'll put that in the tester. We'll run that one through as well. Now it's the same device, so we don't have to change anything. We can just hit test device, hit enter, and there we go. And that one also tests okay. So we'll take that out. We've got one more to test. Keep your finger crossed this one's alright, because if this one's alright, we've got all the 3 RAM ICs we need for the Amstrad. So we'll put this one in, and again we can just hit test, and we will test device. Again it's running through. Okay, that's good. So we now know that those 3 DRAMs there that we need for the Amstrad projects have been tested and they are in working order. What I'm also going to do, we need a hex inverter IC for working on the video on that. Now I have built the circuit up, but for so far I haven't actually tested whether the 7404 that I was using actually works. So I've got the 7404 I was using here. So we might as well test that while we're actually doing this. So we'll take the 7404. I'll get you down back on the Speedmaster, because this actually goes in the Speedmaster slightly differently. Now if we saw before, we had the IC up, basically up there. Now for testing a 7400 series logic IC, it actually goes in the opposite. It actually goes in down there like that, the pin 1 pointing the other way. So we've got that locked in position there now. I'll get you back up onto the screen so you can see what's going on. And if I was really professional, I'd do this all with jump cuts and things, wouldn't I? But I'm not very professional. There you go, you can see the screen well enough. So what we need to do now, we will come out of that, so we go back to the main menu, and we'll go up to 7400 series library, click on that, let the software load again. This is all running off just a 720k floppy disk as well. Right, and then we can, this is another really nice thing, this can actually find a match, so you could put an unknown 74 series logic IC in here and it will actually try and figure out what it is. So if we can actually try that. In fact, yeah, let's try that. Let's see if it can find a match. Now in fact, I'm just wondering if I put that IC in the I might, is it going to find anything? I may have actually put that IC in the tester the wrong way around. We'll see in a second. So if it doesn't find anything now, no, we just spin that IC round. So I made a mistake then. It actually goes, it still goes at the bottom of the IC tester, but it actually goes with the pin 1 pointing up. Let's try that again. See if we can find a match this time. It's already come straight up straight away. Have a look here, matches. It's found it as a 7404 or a 7414. Now they're basically both virtually the same IC. They've got a slight difference. They are pin compatible, so it's actually found, you know, it has basically identified it. There we go, search complete, and it says matches 7404 or 7414. Now we might as well test it while we're here, so we can select device, and we can go down to 7404, select that, hit test device, And there we go. Device vectors are okay. So that IC is absolutely fine, even though we put it in the tester the upside down. But I'm sure the tester's reasonably forgiving for things like that. So we now know we've got a full set of tested RAM and the 7404 for the inverting the video, tested, ready for the next time we look at the Amstrad PC1512. Well, we've got this going. Go on, we'll test a few more. We'll test a few more of these DRAMs out of the box. Let's see what else we've got here. Right, this is the TMS 4164. So this is a 64K by 1 bit. Just the first one I've dug off the top of the pile. This is actually an RS branded one, so this is a Radio Spares branded DRAM. We'll stick that in the tester. So that goes in at the top of the tester with a pin, as though he was with a pin at the top, pin 1 at the top, as though he was testing a. That is as though he was testing a EEPROM. So we've got to go back to main menu there. We'll go back to DRAM. Yes, we're aware of that. We'll select the device, and it's the first device there. It's 64K by 1 bit. We'll load that up, and we'll hit test device. And there we go, straight away. RAM is okay. We'll see if we've got one more to test. We'll just do one more. Ah, there we go. That's a what have we got here? Right, I think this is a 1 meg by 4 bit. The other one I said I didn't actually think I had any. I think I might have one. I am not 100% sure, but I have a feeling this is a. I don't know the make of it, but I have a feeling this is a 1 megabyte by 4 bits. DRAM, so we'll insert that in the tester. We'll go back up to select device, and we will go down to a 20 pin device. This is that a 20 pin device. Let's count the pins actually, and that'll give us an indication. That's 1, 2, 3, 4, 5. Yes, it is a 20 pin device, so this looks like it is a 1 meg by 4 bit DRAM, which is the biggest we can actually test on this thing. So we'll select that. We'll go test device, hit enter. It's clearing the RAM. It's obviously this is a much bigger piece of RAM, so it's going to take long. Ah, look at that. RAM is bad. So bad at 400H. It's expected that, and it found that. So that is. That one is obviously no good. Let's try one more. Let's see what else we've got. Let's see, we've got another of those. Forgot here. I've got a 256K by 4 bit. Here, let's try that one. See if that one will pass. So really, I've got to go back through this big mess of DRAMs now and actually sort them out properly and put them all back in proper storage boxes, so I actually know what I've got and I can access them easily when I need one. Also, the ZIF socket on this is now, I mean, it's very old, so you've got to be very careful actually getting the IC in the holder properly. throw them back in there, I don't need them for now. Right, so we'll go back to here, we'll select the device. Oh, there's the there we go. Right, select device, and this is going to be a 256K by 4, 20 pins, that's exactly the same part, yep. So we select that, we'll hit test device, again clearing the RAM, and that should get up to 256. There we go. And that's okay. So really that's all there is to it. I'll get you zoomed out a bit now. So essentially with that Speedmaster, it makes it incredibly easy with that setup there. You know, to go I mean, it's going to take me longer to actually sort these out into the actual make, speeds, actual types of DRAM than it is to actually go through with the Speedmaster and actually test them and make sure they're okay and then get them back into their storage boxes. Anyway, actually I'm not going to make this video too long, it was only meant to be a little quickie. So I hope you enjoyed seeing me mess about with that. I hope you can appreciate the setup here and what I was doing with the desk and everything, because this was the whole point behind doing the S4000 desk, was giving me somewhere I could actually set up things like the Speedmaster, a laptop, what have you, for doing like EEPROM programming and testing and stuff like that. So like I said, I'm going to leave it there for now. I hope you enjoyed this video. Thanks for watching and goodbye.